All right, guys. Questions on the homework before we get started. Number.
Well, I was only saying that because I want to. Too bad you can hear them. You ever did just
All right.
I'm waiting. Hey, smell that? It smells like smoke. Have you been thinking so much?
All right, guys. So these here would be the three Kramer's rules. So Kramer's rule, we would have these three sets here. So clear that out. Second matrix. Edit. 3 by 3. Negative 49. Negative 5, 2. Negative 22. Negative 3, negative 8. Negative 3, 8. Negative 5. Second matrix. Over to edit. Second one's going to be a 3 by 3. 6. Negative 49. 2. Negative 5. Negative 22. Negative 8. Negative 3. 55. Negative 5. 6. Negative 5. Negative 49. Negative 5. Negative 3. Negative 22. Negative 3. 8. 85. All right. So once we get all three entered in, second matrix, determinant, second matrix A. Over second matrix, determinant, second matrix D. So 3, 5, 2. 3, 5, 2. No, something's off. Negative 49, negative 22. Figured it out. Negative 3. Second, well. Then we do the same thing, but instead of A, we would have B. And we do it one more time. Instead of B, we would have C. So we should get negative 3, 7, 2. All right. Sawyer Sherrill came to watch me play hockey, so they made that poster. Because men's hockey league, or kind of just men's league, is called beer league. All right, guys. What we're looking at today is inverse matrices and systems of equations.
I have a question. Are you ever gonna have to like do like a problem that has like stuff in it and you want us to find the matrix of it?
We did some at the beginning of the year, but because we did the augmented matrix rewriting a 3-variable system as a matrice. But most of it, we'll do it here and there, but not really consistently.
We're never gonna like do all this.
Not at this point. Normally we do test over this, but just pushing up against Thanksgiving break, we end up just not having time.
Yeah. Because it's like, you gotta do this, and I was like, no. I was like, and she was like complaining about matrices, and I was like, that's easy, that's not gonna hard. And she's like, no, you have to do it yourself. And I was like, we didn't focus on that. And she was like, we didn't either. And she's like,
Doing the matrice by yourself.
yeah, like you have like, but I mean, no one specifically. It wasn't like that. You had to. It was like the.
I think I know what you're talking about. There we go. So, go for it.
Yeah, I think so.
And it's wanting you to find the inverse of this matrix? Yes. So what we're doing is, and this is part of what we're doing here, we won't do it this way. Because to find an inverse, one of the ways is to set this up. And we can do what they call row manipulation. So adding and subtracting the rows, manipulating the rows. And if we can get, or well, sort of this side to become this here, then this side here is the inverse of the matrix. Now for a 2 by 2, that's not going to be here, it's here nor there. 3 by 3, this is more of the way if you're going to do it by hand, you would do it by hand. Because there is a nice formula for 2 by 2s. Now what we're going to do first is determine if two matrices are indeed inverses of each other. Now the way to determine that is if two matrices are indeed inverses, if we multiply them together, if we multiply the two matrices together, we'll get the identity. And the identity matrix is our 1, 0, 0, 1. So if we get that there, that is our identity. And it has to be 1, 0, 0, 1. Those diagonals have to be 1. If the diagonal is 2 and 2, not inverses. It has to be 1 and 1. So what we would do is we take matrix A, -4, 2, -2, 1, and we're going to multiply it by our matrix B, 1/4, -1/2, 1/2, -1. And if we multiply these two matrices together and we get the identity matrix, then they are indeed inverses. Now, yes, we could type these in the calculator, let it do it for us, and see what the inverse, if it is inverses. Here, I'm going to go on and do this one by hand. So we go over and down. So we'd have -4 times 1/4 plus 2 times 1/2. Then we'd go over and down again and have 4 times -1/2 plus 2 times -1. Now we move to the second row, which would be -2 times 1/2 plus, or not 1/2, 1/4 is -2 times 1/4 plus 1 times 1/2. And then lastly, -2 times -1/2 plus 1 times negative 1. So we're doing our multiplication out. Now at this point here, we can simplify. So our negative 4 times 1/4 would be negative 1. 2 times 1/2 is plus 1. 4 times negative 1/2 would be negative 2. Make sure. Drop the negative, because that should be positive 2. 2 times negative 1 is negative 2. At the bottom, negative 2 times 1/4 is negative 1/2. 1 times 1/2 is plus 1/2. And lastly, negative 2 times negative 1/2 is 1. And 1 times negative 1 is negative 1. And indeed, we end up with 0, 0, 0, 0. So this is, are these inverses? No, they're not inverses because we did not get the identity. You're welcome. So. Questions on this here? How we determine if the two are inverses? Okay. Now, we don't have to do these by hand. We can actually do these in the calculator. So let's look at the second one here. So we're given F is 3, negative 5, negative 2, 6. And G is 3/4, 5/8, 1/4, and 3/8. I'm going to grab the calculator, say second matrix. Over to edit. We'll put the first one in as A. 2 by 2. So we have 3, negative 5, negative 2, 6. So we get the first one typed in. Second quit, second matrix. Over to edit, matrix B is also a 2 by 2. Now there's two ways we can type this in, because we can do alpha y equals all 4 times. But a fraction is just another way to do what? 3 divided by 4. 5 divided by 8. Divided by 4. And that last one's not right. There we go. Because we can have it as fractions or as decimals at this point, doesn't really matter. It's going to know the difference. Part of the reason I just use division is it's a lot quicker than having to do alpha y equals every single time. Yes. And once we get it typed in, second quit, we can go second matrix A, second matrix B, and A times B is 1, 0, 0, 1. It is the identity, so they are indeed inverses. Let's try something. Let's say matrix B times A. Because if two functions are inverses of it, it doesn't matter the order. A times B is equal to B times A equals the identity, then they are indeed inverses. It doesn't matter which way we go. Because they're opposite. They undo each other.
So do we always just have to get 1, 0, 1?
Yep, we have to get this here. Now, if it gave us, say, 2, 0, 0, 2, they're still not inverses. It has to be the ones. Questions on determining if two functions are inverses? Questions on how we plug something in?
Wow.
We feel comfortable with these here. All right. Now, we're going to find the inverse of a 2 by 2 matrix. Now, as I was mentioning earlier, where we had the matrix and then had the 1, 0, 0, 1, that is a way to find the inverse. It's a little bit longer and there's more to it. And for 3 by 3s and above, because it has to be a square matrix, we have to kind of go that way. That's really the only way to get to the inverse. But for 2 by 2s, we do have this nice formula. We have 1 over AD minus BC times our matrix. Now the matrix that we're multiplying it by, if you notice the A and D, the top right and bottom left, flip positions. We switch those two, and the other two numbers, we flip the sign. If it was negative, it becomes positive. If it was positive, it becomes negative. Now one thing that's interesting is also we're saying that AD minus BC cannot be 0. Can't be 0. Can't be 0 because that AD minus BC shows up right here. So if it is 0, we have 1 over 0. We cannot divide by 0. So it doesn't work. It doesn't have an inverse. Not every matrix will have an inverse. Some will, some won't. But realistically, this AD minus BC is just the determinant of matrix A. So if a matrix determinant is 0, it does not have an inverse. It's not invertible. So if we look at this here to find T inverse, we're going to take 1 over AD, 7 times negative 1, minus BC, negative 5 times 2. Questions on this so far? Huh? Now at this point here, for the matrix itself, we're going to take the 7 and negative 1 and switch them. So the negative 1 is going to be in 7's place, and 7 is going to be in the negative 1's place. We switch those two. So it's part of the formula here. So we're going from, so the A, when it comes over here, is down below. The D goes in its spot. So A and D switch. Now B and C, we go from B to negative B, C to negative C. So they don't switch, but we change their sign. So here the 5 is negative. It's going to become positive. The 2 was positive. It's now going to become negative. Now we just simplify. So the next thing we're going to do is simplify this here. So we still have 1 on top. 7 times negative 1 is negative 7. Minus negative 5 times 2 is negative 10. But the negative negative makes a plus. The matrix is still going to be negative 1, 5, negative 2, 7. Negative 7 plus 10 is positive 3. Questions on this here? Question on anything we've done so far? Multiply through. So we're going to do 1/3 times negative 1, which is negative 1/3. 1/3 times 5 is 5/3. 1/3 times negative 2 is negative 2/3. And lastly, 1/3 times 7 is 7/3. That's it. Yes. 3 by 3s or even more. Questions on this here? We ready for the next one? All right. So we want to determine if we want to find the inverse of q. So q to the negative 1, q inverse. So we're going to have 1 over negative 8 times 9 minus negative 6 times 12. AD minus BC. Inside our matrix, the 9 and negative 8, so our A and D switch places. And the C and B flip signs. So B and C, if they were positive, they become negative. If they're negative, they become positive. We're just changing the sign. Questions on this here? Let's simplify this fraction out front. Negative 8 times 9 is negative 72. Minus 6 times 12. Negative 72. The negative and negative make a plus, yes? Wait a minute. What's negative 72 plus 72? Not invertible. There is no inverse. No inverse. Not invertible. Or we can say does not exist. So Q inverse, there is no Q inverse. We cannot take the inverse of Q. No, it just doesn't work. Because of that division of 0, there's no way to offset it. It just doesn't have an inverse. Okay. Questions on this here? Let's look at 2a. 3, 7, 1, negative 4. Type that into your calculator. Yep, type it in matrix form. So 2a, put that in matrix form. Okay. Is everybody able to get it typed in? So the first thing we want to do, second matrix A. Okay? Hit the matrix button again. That x to the negative 1. So it gives us that matrix A to the negative 1, yes? Hit enter. But we don't want it as decimals, we want it as fractions, so we can go math, enter, enter. Math, enter, enter. 4 ninths, 7 ninths, 1 19th, and negative 3 19ths. That's it. That's the answer. That's the inverse. Yeah. Yep. So A to the negative 1, A inverse. So the 1/3 is what we had to multiply through to get to it. And that's the nice thing with this here, especially even if it's a 3 by 3, doing those exact steps would actually get us the inverse of it. Questions on how to find an inverse, if it exists? I feel good with this here. Last thing we're going to do is solve systems using matrices, using specifically inverses. Now to do this, what we'll do is we can take this equation here and we'll split it up. So we have a matrix of the left side and we have a matrix of the right side. Now the left side we can rewrite as a product of A, the coefficients, times xy equals our numbers. Now the reason we break it up this way is for one specific reason. And this here is our AB and our xy. Because if we multiply this matrix over here by A inverse times A is the identity, which for matrices is the equivalent of multiplying by 1. So those matrices becomes the identity or just our x, this xy. And this product of A inverse times B will be the solution. So let's actually look at it in context of the problem. So here we have 3 matrices. The first is just the coefficients. Bless you. -7, 2, 6, 6. And it's being multiplied by xy, the matrix xy, and it's equal to our matrix 18, 0. So what we have here, we'll call this B, A, and this is B. So we have A times this matrix, xy is equal to B.
May I have your attention? May I have your attention, please? If there is anyone else who would like to donate blood, they are still up at the community center, and they are needing more people to donate. So if you are interested in donating, you need to go up to the community center at this time. Thank you.
Now our A inverse times A over here is going to become the identity matrix, or 1, so it's going to go away. Now we need to do A inverse times B. Then we'll type this in. It would cause a lot of strain on your heart, because it would cause issues, because it's pretty much your heart's still going to try to do the same function it's doing with less. So it's almost, I don't know if y'all have worked with water pumps or kind of just pump valves, because the less water that the valve has to pull, it has to work harder to do the same amount of work. Which if it's left at that low volume for too long, it's going to burn the pump out. It'll do the same strain on your heart. They highly suggest that you don't do any high exercise after giving blood. Because, yeah.
That's why I was thankful that I had to take a test this year.
So, all right, guys. So 2 by 2. So -7, 2, 6, 6. So we're typing in the coefficients, the numbers in front of xy. For 1, second quit, second matrix. Now matrix B is going to be a 2 by 1. It's going to be what it's equal to. So the equation for the first one's equal to 18, and the other is 0. Second quit. Second matrix.
They want to go get blood. Don't ask for it.
Are y'all wanting to go? Yeah. Before y'all head out. And Hannah, remember what did I say, 7:50 tomorrow? Or no, 8:50. All right. So we get matrix A back, and we're taking the inverse. Now we're going to have to multiply that by matrix B. And if we multiply those two together, we should get a 2 by 1. And we get this here, -2, 2. Which is telling us the solution is the point, -2, 2. X is on top, Y is on bottom. That's it. Yeah. And especially if you're doing this in the calculator, doing RREF, our reduced row epsilon form, is almost faster than doing this here. But that's it.